Welcome to the final lesson of Chapter 5, Clustering and Accessing Data. We've covered storage choices and caching strategies. Now we need to address what happens when a single host is no longer enough. This is the world of data clustering and replication. At some point in your application's growth, you will watch your single host scream for resources. Average CPU load will creep up, gradually eating all your processors. When that moment arrives, you need to add a host to keep performance stable and allow your dataset to continue growing. This transition from one host to two sounds simple but is actually one of the most complex operational changes you will make. The most common first step is database replication. Most database services support replication, where your dataset is copied from one host to one or more replica hosts. Your application can then connect to any of those hosts. The diagram in the book shows two DB instances with a bidirectional replicate arrow between them, and the application able to access either one. Replication comes in two main flavors. In multi-master replication, the dataset is stored and duplicated across two or more hosts, and data can be updated on any of them. All hosts are called members, and since there is no partitioning, every member handles client requests. The advantages are significant. There is no single point of failure since every member is a master, and hosts can be geographically distributed to serve clients with lower latency. However, multi-master replication also has real disadvantages. In asynchronous mode, the system is not guaranteed to be consistent. A network interruption before data is replicated to another host means your members momentarily disagree. In synchronous mode, you get consistency but at the cost of latency. The server will not reply until data is replicated, and network failures can stall your entire application. And here is the critical caveat: replication alone does not help you scale storage. Your full dataset lives on every server. For huge datasets, this wastes enormous space. The better path for true scale is genuine clustering, where your data is partitioned and each partition is replicated on at least two hosts, similar in concept to RAID 5 on disks, but without the write hole vulnerability. Now that we understand how data is distributed across hosts, we need to talk about how your application accesses that distributed data reliably and efficiently. This is where application architecture meets data architecture. Your application needs to be aware of replication members and use them intelligently. The simplest approach is random selection. Your application knows the list of replica hosts and picks one randomly or round robin for each request. This provides basic load distribution. However, your application or database module must also be able to detect failures and reroute requests away from a failed host automatically. A more sophisticated topology introduces a proxy layer between your clients and your application instances. In the book's diagram, you have two replicated database instances, two application instances each connected to both databases, and a proxy layer beneath that routes incoming user traffic to the appropriate application instance. This enables two important capabilities. The proxy can route users based on geographic location for lower latency, and it can distribute load based on which application instance is currently under less pressure. This topology also surfaces a critical requirement: your application must be stateless. If the proxy can send any user to any application instance, then that instance must not hold any user-specific state in memory. Session data, for example, must live in the shared cache. Redis is the canonical answer here, not in the application process memory. Choosing the right underlying data technology matters enormously for this topology. If your application depends on a file system, shared files between instances, you need synchronization between hosts, which is non-trivial. BlusterFS is one option for distributed file system access. If you need object or blob storage, Ceph or MongoDB's GridFS are natural fits. If you need a highly scalable data storage server that is designed from the ground up for distributed access at massive scale, Apache Cassandra is the recommendation the book makes explicitly. Prepare your application to use it from day one, and you will not regret it. The summary from the chapter is worth internalizing. Data is critical. Plan its structure early, cache aggressively for the most accessed portions, and remember that replication and clustering are not substitutes for a proper backup plan. Value your data, it is the one thing you cannot recreate. Let's close out Chapter 5 with a consolidated view of the principles we've covered and the decisions you need to make for a high-performance Node.js data layer. The first principle is, choose your storage thoughtfully and early. Files work for tiny datasets, but a real DBMS is almost always the right answer for production applications. Prioritize scalability and consistency over raw speed when making that choice. And remember, deep familiarity with one good tool beats shallow knowledge of many perfect tools. The second principle is, eliminate unnecessary I/O. Every disk read or database query that can be avoided should be avoided. Load data once at startup where possible, hold it in memory, and flush changes through a single coordinated write channel. When that is not enough, bring in a proper DBMS. The third principle is, cache strategically and correctly. Identify the data that is read frequently and changes rarely, that is your caching opportunity. Use the cache-aside pattern. Be aware of the thundering herd problem in async environments and implement the callback queue pattern to prevent it. Use Redis for shared, structured caching across multiple application instances. The fourth principle is, plan for scale before you need it. Sketch your replication topology early. Decide whether replication or genuine clustering is right for your dataset size. Understand the consistency trade-offs in asynchronous versus synchronous replication. Make your application stateless so that adding new instances does not require architectural surgery. The fifth and most important principle is, protect your data. Replication is not a backup. Clustering is not a backup. A backup is a tested, restorable snapshot of your data stored separately from your production infrastructure. Automate your backups, test your restores, and run those restore trials on a separate host. Your users might forgive a brief outage. They will never forgive permanent data loss. In the next chapter, we will move to testing, benchmarking, and analyzing your Node.js application, because a high-performance application is only trustworthy if you can measure and verify that performance under realistic conditions.